Jai Shri Gurudev. Good morning to everyone, students. Welcome to chemistry class. In the previous class, we learned the limitations of orbital overlapping concept. So after knowing the limitations of orbital overlapping concept, we are going to study the concept of hybridization. This hybridization concept is very important in order to explain the stability and shape of the molecule. The scientist Pauling was successfully explained the stability and shape of the molecule by the phenomena of hybridization. Okay, so hybridization is defined as the atomic orbitals are overlapping together and give an equal number of hybrid orbitals. That process is called as hybridization. These hybrid orbitals having equal number or equal amount of energy. Okay, so hybridization is one of the process which is explained by Pauling scientist. He says that the orbitals means atomic orbitals of an atom having same energy. It means almost same energy or comparable energy orbitals are overlap or combined together to form an equal set of orbitals. Those we called hybrid orbitals, and that phenomenon we called as hybridization. This hybridization successfully explained the stability of molecules, means heteroatomic molecules. Now, some important features are there to know the hybridization, that is called important features of hybridization. So here the important features of hybridization is number of hybrid orbitals is equal to atomic orbitals. The first one, number of hybrid orbitals is equal to the atomic orbitals. So now observe, hybridization is nothing but, you know well, already I told you the definition. The atomic orbitals of an atom, atomic orbitals, for example take carbon, its atomic number is 6, then electronic configuration is 1s2, 2s2 and 2p2. Okay, so here valence shell electrons is 2s2 and 2p2. In S there is a 2 electrons with opposite spin, and 3 in P there is 3 orbitals. Okay, 3 orbitals, that is 1, 2 electrons. Here 2px and y and z. Okay, this is px, py and z under the second shell. Now this is 2s orbit, this is 2px, 2py and 2pz orbitals. These atomic orbitals, these 3 means 1, 2, 3, 4. These 4 orbitals we called as atomic orbital. These atomic orbitals is equal to number of hybrid orbitals. Hybrid orbitals is nothing but all these atomic orbitals are combined together to give a orbitals that we call atomic orbit, hybrid orbitals. Here there is 1 2s orbit. How many 2s orbits are there? 1 2s orbit plus 3 2p orbit, 3 2p orbits. 1 2s orbit and 3 2p orbit. Totally how many orbitals you get? 4. 3 plus 1 4. S p, S p, 1 s 3p. Okay, totally get 4 sp3 hybrid orbitals. Here no need to mention sp3. Total you get 4 hybrid orbitals. That is says that first important feature of hybridization is number of hybrid orbitals is equal to atomic orbitals. Got it, students? Then the second one, hybrid orbitals is always having equal energy. These hybrid orbitals always having same energy or equal energy. Okay, the resultant hybrid orbitals having same energy. Then hybrid orbitals are more preferable to form a bond than atomic orbitals. The third one is hybrid orbitals are more preferable to form bond than atomic orbitals. This is the third one. Then the fourth one, hybrid orbitals is oriented in their preferred direction in order to minimize the repulsion from lone pair electrons that gives the geometry of a molecule, a shape of the molecules. Then fourth one, hybrid orbitals are prepared to orient in the direction. Hybrid orbitals are oriented in the preferred direction. Hybrid orbitals are oriented in preferred direction. So the hybrid orbitals are oriented in preferred direction in order to minimize repulsion from lone pair electrons. Lone pair LP means lone pair electrons. Lone pair electrons. That is shape or geometry of compound and molecule. Okay. So this is the fourth one. Observe, the hybrid orbitals are oriented in preferred direction. ಅಂದ್ರೆ ಹೈಬ್ರಿಡ್ ಆರ್ಬಿಟಲ್ಸ್ ಯಾವ ಡೈರೆಕ್ಷನ್ ಬೇಕೋ ಅದೇ ಡೈರೆಕ್ಷನ್ ಓರಿಯೆಂಟ್ ಆಗ್ತಾ ಇರುತ್ತೆ. ಯಾವ ರೀತಿ ಓರಿಯೆಂಟ್ ಆಗುತ್ತಂದ್ರೆ ಲೋನ್ ಪೇರ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇಂದ ರಿಪಲ್ಷನ್ ಅನ್ನೋದು ಕಡಿಮೆ ಆಗಬೇಕು. ಓಕೆ, ಯೂಶುವಲಿ ನೆಕ್ಸ್ಟ್ ಥಿಯರಿ ಹೇಳುತ್ತೆ, ಮೆಸ್ಪರ್ ಥಿಯರಿ ಅಂತ ಬರುತ್ತೆ, ವೇಲೆನ್ಷಿಯಲ್ ಎಲೆಕ್ಟ್ರಾನ್ ಪೇರ್ ರಿಪಲ್ಷನ್ ಥಿಯರಿ ಅಂತ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡುತ್ತೆ. ಅದು ಹೇಳುತ್ತೆ ಲೋನ್ ಪೇರ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಅನ್ನೋದು ತುಂಬಾ ರಿಪಲ್ಷನ್ ಇದೆ, ಲೋನ್ ಪೇರ್ ಅಂಡ್ ಬಾಂಡ್ ಪೇರ್, ದೆನ್ ಬಾಂಡ್ ಪೇರ್ ಅಂತ ಹೇಳುತ್ತೆ. ಆ ಲೋನ್ ಪೇರ್ ಅಲ್ಲಿ ನಾವು ರಿಪಲ್ಷನ್ ಕಡಿಮೆ ಆಗೋದಕ್ಕೆ ಏನಾಗುತ್ತೆ, ಹೈಬ್ರಿಡ್ ಆರ್ಬಿಟಲ್ಸ್ ಅವ್ರಿಗೆ ಯಾವ ಡೈರೆಕ್ಷನ್ ಬೇಕೋ ಆ ಕಡೆ ಓರಿಯೆಂಟ್ ಆಗುತ್ತೆ. ಆ ಓರಿಯೆಂಟ್ ಆಗೋದ್ರಿಂದ ಶೇಪ್ ಅಥವಾ ಜಾಮೆಟ್ರಿ ಆಫ್ ಕಾಂಪೌಂಡ್ ನಾವು ಡಿಸೈಡ್ ಮಾಡಬಹುದು. ದಟ್ ಈಸ್ ದಿ ಫೋರ್ತ್ ಒನ್. These are the some important features of hybridization. After knowing the important feature, we are going to study the important conditions of hybridization. The next one is important conditions of hybridization. The next concept is importance of, that is important conditions of hybridization. What are the important conditions to hybridize atomic orbitals? The first one is valence shell orbitals are involved in the hybridization. Valence shell orbitals are only involved in hybridization. So you know, already I told you, the hybridization of carbon, the outermost valence shell electrons is 1s2, 2s2 and 2p2. This is the valence shell, right? This valence shell orbitals only involved in the hybridization. That is the condition 1. Then the second one is hybrid orbitals is always having same energy, almost same or similar energy. Those only involved in hybridization are they only involved in hybridization. The hybrid orbitals should always have same energy. Same energy. Such type of orbitals will be involved in the hybridization. Then the fourth one, promotion of electrons may or may not be takes place in the hybridization. It is not an essential condition. Promotion of electrons is not necessary. means not an essential condition. Necessary or not an essential condition. In some cases, electrons are promoted from ground state to excited state before going to the hybridization, and in some other cases, the promotion of electrons not takes place. So that the promotion of electron is not an essential condition. Then these atoms may or may not in excited state before the hybridization. ಅಂದ್ರೆ ಈ ಆರ್ಬಿಟಾಲ್ಸ್ ಎಕ್ಸೈಟೆಡ್ ಸ್ಟೇಟ್ ಗೆ ಅಟಾಮಿಕ್ ಆರ್ಬಿಟಾಲ್ಸ್ ಅನ್ನೋದು ಎಕ್ಸೈಟೆಡ್ ಸ್ಟೇಟ್ ಗೆ ಮೂವ್ ಆಗೋಕ್ಕಿಂತ ಮುಂಚೆನೆ ಹೈಬ್ರಿಡೈಸೇಷನ್ ಆಗಬಹುದು ಅಥವಾ ಗ್ರೌಂಡ್ ಸ್ಟೇಟ್ ಅಲ್ಲೇ ಹೈಬ್ರಿಡೈಸೇಷನ್ ಆಗಬಹುದು. ಅದನ್ನೇ ಹೇಳ್ತಾ ಇರೋದು ಎಲೆಕ್ಟ್ರಾನ್ ಪ್ರಮೋಷನ್ ಆಗಬಹುದು ಅಥವಾ ಹಾಗಿರೇ ಇರಬಹುದು. ದೆನ್ ಆಫ್ ಫೀಲ್ಡ್ ಅಂಡ್ ಫೀಲ್ಡ್, then even empty orbitals also involved in the hybridization. The last one very important, half field or filled or even empty orbitals also. Empty orbitals also involved in hybridization. Involved in hybridization. It means half filled orbitals. Half filled orbitals means take a carbon. Atomic number 6, 1s2, 2s2 and 2p2. Here observe in P there is 3 orbitals and in S 1 orbital. Here there is 2 electrons. Here 1, 2, this is empty. So observe here off field. These are off field, right? 1 electron is there. These are off field. Then field. This is field 1. Then even empty. This is empty orbital. All these 3 are involved in the hybridization. That doesn't matter. Okay. So ಯಾವ ಆರ್ಬಿಟಲ್ಸ್ ಆದ್ರೂ ಇನ್ವಾಲ್ವ್ ಆಗಬಹುದು. ಎಂಪ್ಟಿನೇ ಇನ್ವಾಲ್ವ್ ಆಗಬೇಕು, ಆಫ್ ಫೀಲ್ಡ್ ಇನ್ವಾಲ್ವ್ ಆಗಬೇಕು ಅಥವಾ ಕಂಪ್ಲೀಟ್ಲಿ ಫೀಲ್ಡ್ ಆಗಿರೋದೇ ಇನ್ವಾಲ್ವ್ ಆಗಬೇಕು ಅನ್ನೋ ರೂಲ್ಸ್ ಏನಿಲ್ಲ. These are the some conditions to form hybridization. Okay. Now examples we are going to study some types of hybridization. After knowing the conditions, we are going to study types of hybridization. Then next concept is types of hybridization. Here there are various types of hybridization is formed by involving S, P and D orbitals. Okay, already you know types of orbitals. S, P, D and F orbitals are also there. Here in your class, means under your second class level, we have studied only S, P, D orbital hybridization. By overlapping these orbitals, you get different types of hybridization. Those here we have studied one by one. Okay. Now first one, take sp hybridization. First one, sp hybridization. sp hybridization. sp hybridization is nothing but the overlapping of S and P orbitals to form a hybrid orbital. That process we called as sp hybridization. In sp hybridization, there is 50% of S character and 50% of P character. Okay, you know the percentage is calculated by 100. Okay, ನಾವು ಯಾವಾಗಲೂ ಅಷ್ಟೇ percentage 100 ಗೆ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತೀವಿ. ಅದೇ ರೀತಿ S P ಅನ್ನು ಇಲ್ಲಿ ನೋಡಿದಾಗ 100% ಅಲ್ಲಿ 50% S ಇದೆ, 50% P ಇದೆ. Because 1 S and 1 P is only there. Okay, ನಾವು 100% ಅಂತ ತಗೊಂಡಾಗ ಎಷ್ಟಿದೆ, ಒಂದೇ ಒಂದು S 1 P ಇರೋದ್ರಿಂದ ಡಿವೈಡ್ ಬೈ 2 ಮಾಡಿದ್ರೆ 50 ಬಂತು. 50% ಅಲ್ಲಿ S ಅನ್ನೋದು 50% ಇದೆ, ಅದೇ ರೀತಿ P ಅನ್ನೋದು ಎಷ್ಟಿದೆ, 50% ಇದೆ. Okay, got it? So this is the way to calculate SP percentage. In SP hybridization, there is 50% of S character and 50% of P character. Then you know this S is spherical in shape. There is no orientation. And in P, it has orientation, that is in 3 possible direction. One is S direction, and one is p direction, and one is x direction, and one is y direction. This is like assume y direction, and this is x direction, and one is z direction. This is z direction. Okay, this is the way of orientation of p orbitals. Now these s orbit and p orbitals overlap together to form a sp hybrid orbit. Sp hybrid orbital. That sp hybrid orbits having same energy and involves in the hybridization, then that will be make a strong bond with neighboring hybrids. Okay, that sp hybrid orbitals is decided the geometry of a molecule or shape of a molecule. Here s and p orbitals overlap together to give a sp hybrid orbital that is in linear shape, so that the bond angle is 180 degree and the shape of the molecule we called as a linear shape or linear geometry or linear hybridization. Okay, so here observe how the s and p orbitals overlap. Now let's take this is the s orbital and this is p orbit, right? Either let's consider this is y or x or z, your wish. Now take any one among these three. Let us assume this is the p orbital. Here we don't need the direction of the orbit, so just write the p orbit. This is s orbit and p orbit. Now this s and p atomic orbitals. This is one atom orbit, and this is one atom orbit, or both are same atom orbit. Okay. Now these two s and p orbits overlap to get sp hybrid orbital. That sp hybrid orbital is like that. This is the sp hybrid orbitals. These small peaks we call as negative lobes, and these we call as positive lobes. Okay, so like that the s and p orbital overlap and you get sp hybrid orbital. This is hybrid orbitals, this is atomic orbitals. Okay students, I hope you understand what is the difference between atomic orbitals and hybrid orbitals. These atomic orbitals is from an atoms. After overlapping these two atomic orbitals, the resultant one we called as hybrid orbital. These hybrid orbital having same set of energy. These two either may same or almost similar, not much variation in energy. Energy ತುಂಬಾ ವೇರಿಯೇಷನ್ ಇದ್ರೆ ಹೈಬ್ರಿಡೇಷನ್ ಆಗೋದಿಲ್ಲ. ಸೊ ಆಲ್ಮೋಸ್ಟ್ ಸೇಮ್ ಇರುತ್ತೆ, ಇಲ್ಲಾಂದ್ರೆ ಸ್ವಲ್ಪ ನಿಯರ್ ಆಗಿರುತ್ತೆ, ಇಲ್ಲಾಂದ್ರೆ ಈಕ್ವಲ್ ಆಗಿರುತ್ತೆ. ಅಂತ ಕೇಸಲ್ಲಿ ಮಾತ್ರ ಹೈಬ್ರಿಡ್ ಆರ್ಬಿಟ್ ಅಟಾಮಿಕ್ ಆರ್ಬಿಟಲ್ಸ್ ಅನ್ನೋದು ಓವರ್ಲ್ಯಾಪ್ ಆಗುತ್ತೆ. ಓಕೆ, ಸೊ ದಿಸ್ ಇಸ್ ದಿ ಓವರ್ಲ್ಯಾಪಿಂಗ್ ಆಫ್ s and p atomic orbitals and form hybrid orbitals of an s and p. Now example we are taking beryllium chloride. There we know how the atomic orbitals are overlapped. For sp hybridization, take example beryllium chloride. Beryllium chloride, BeCl2. Now what is the atomic number of beryllium? Hydrogen 1, helium 2, lithium 3, beryllium 4. Okay, the atomic number is 4. Now write electronic configuration 1s2 and 2s2. Okay, 4 2s2. After 2s2 there is a 2p empty orbital right in outermost shell. Now this is the variation electronic configuration. Now write in its orbitals s and p. How many orbitals are there in p? 3 electrons, 1 2. Here no electrons. Okay, this is the electronic configuration in what? Ground state. So observe in the conditions of hybridization I told you, the promotion of electrons may or may not be required ಅಂತ ಹೇಳಿದೆ, ಅಂದ್ರೆ ಎಸೆನ್ಷಿಯಲ್ ಅಂತ ಹೇಳಿದೆ. ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಜಂಪ್ ಆಗಬಹುದು ಅಥವಾ ಹಾಕಿರಾದ್ರೂ ಇರಬಹುದು ಅಂತ. ಸಮ್ ಕೇಸಸ್ ಅಲ್ಲಿ ಜಂಪ್ ಆಗುತ್ತೆ, ಸಮ್ ಕೇಸಸ್ ಅಲ್ಲಿ ಜಂಪ್ ಆಗೋದಿಲ್ಲ. ದಟ್ ಈಸ್ ಡಿಪೆಂಡ್ಸ್ ಆನ್ ದಿ ಟೈಪ್ ಆಫ್ ಕಾಂಪೌಂಡ್ ವಿಚ್ ಈಸ್ ಫಾರ್ಮ್ಡ್. Okay, now here observe two chlorines are there, so that it should need to jump one electrons from the s to p orbitals, because both are present in the same shell. ಎರಡು ಒಂದೇ ಶೆಲ್ ಅಲ್ಲಿ ಇರೋದ್ರಿಂದ electrons jump ಆಗುತ್ತೆ. That is we called excited state. Excited state. So jump ಆಯಿತು ಅಂದ್ರೆ ಏನಾಯ್ತು, one electron ಇದರಲ್ಲಿತ್ತು, remaining p ಅಲ್ಲಿ ಎಷ್ಟು electrons ಇದೆ? 1 2. ಇಲ್ಲಿ ಬಂದಿದೆ. So this is from s and this is from p. Now this s and p atomic orbitals S ಅನ್ನೋದು ಸ್ಪೆರಿಕಲ್ ಅಟಾಮಿಕ್ ಆರ್ಬಿಟಲ್, P ಅನ್ನೋದು ಡಂಬಲ್ ಅಟಾಮಿಕ್ ಆರ್ಬಿಟಲ್. ಇವೆರಡು ಕಂಬೈನ್ ಆಗಿದ್ದು ಏನಾಯ್ತು S and P hybrid orbitals ಆಯ್ತು. ಯಾವ ತರ ಆಯ್ತು ಕಂಬೈನ್ ಆಗಿದ್ದು sp hybrid orbitals. This is an sp hybrid orbitals, right? Like that we get. This is S and this is P, called sp hybrid orbitals. Got it? Now these two combine together you get sp hybridization. So this is the this is the hybrid orbital of what? Beryllium. Beryllium na hybrid orbital how bantu sp ತರ ಬಂತು. Now here there is a chlorine. What is the atomic number of chlorine? 17. Now electronic configuration is 1s2, 2s2, 2p6, then 3s2 and 3p5. Okay. Now writing its orbital, this is the outermost shell. In S it is completely filled. In 3s and 3p 1, 2, 3, 4, 5. Okay. There is only one empty. One singly occupied, unpaired orbital. This one unpaired orbital that is from 3p. You know p is jumper shape. Okay. This is overlapped with this hybrid orbitals and form a linear beryllium chloride. Observe how it is formed. Now observe the structure. Beryllium hybrid orbit is this one, sp. So take beryllium. This hybrid orbit is like that. Now observe. This is the beryllium, right? Beryllium hybrid orbit. Its geometry is what? Hybridization is what? sp. Now there are two chlorine atoms. For one chlorine, the valence shell having only one electron in p orbit, that is double, like that. Now that is overlap like. This is p orbit overlap. Of what? This is from chlorine, Cl right here. Now similarly one more chlorine is there, right? That will be overlap here. This is chlorine. Now this is what? Beryllium, chlorine and chlorine. Beryllium, bond, chlorine. This is overlapping called as what? Bond. And this is bond. Here there is chlorine, that is called chlorine. Now the bond angle of chlorine, beryllium, chlorine. This is what? Linear, right? The bond angle is how much? 180 degree. Okay. In the previous case, in orbital overlapping concept, we told that p orbitals are perpendicular to one another like that. P orbitals are perpendicular to one another, like one is x direction, one is y direction and one is z direction, like that. Now here the bond angle is how much? 90, we told right there. But here overlapping of orbitals p and s orbitals, you get the bond angle is 180, that is like a straight line, hence the shape of the molecule we called as linear. Okay, like that we are deciding the shape of any molecules. So here the beryllium chloride hybridization is what? sp hybridization and geometry is linear. Got it? It means all sp hybrid orbitals, sp hybridization molecules having linear geometry. Now take one more example, that is ethylene. Take example 2, ethyl molecule. Example 2, ethyl. What is the molecular formula of ethyl? C2H2. This is ethyl, right? C2H2. How many carbons are there? 2 carbons. And how many hydrogens? 2 hydrogens. You know the structure. H bond, C triple bond, C bond, H. Now observe, by the chemical bonding and molecular structure chapter, we are going to know how the bonds is formed between carbon and hydrogen, and what are the theories which helps to explain to know the structure. Okay, that is only our concept or understanding under this chapter. Now see how it is formed. Let's take the carbon, first element. Carbon atomic number is 6 and the electronic configuration is 1s2, 2s2 and 2p. Okay, now write in orbital diagram. This is the valence shell, 2s and 2p. There is 3 orbitals. 2 electrons and 1 2. So this is the electronic configuration in ground state. Now in excited state, one of the electron present in 2s is James 2 what? 2p orbital. Why it is James? Because both having same energy. ಎರಡಕ್ಕೂ ಒಂದೇ ಶೆಲ್ ಇದೆ, ಸೇಮ್ ಎನರ್ಜಿ ಇರೋದ್ರಿಂದ ಏನಂತೆ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಜಂಪ್ ಆಗುತ್ತೆ. Now observe here. This is the electronic configuration of one carbon. How many carbons are there here? 2 carbons. Similarly for second carbon, same like that. Now, how many hydrogens are there? 2 hydrogens. Each hydrogen having 1 electrons. Now divide these two. It means for one carbon, 1 hydrogen get, right? ಇಲ್ಲಿ 8 ಕಾರ್ಬನ್ ಇದೆ, 2 ಹೈಡ್ರೋಜನ್ ಇದೆ. ನಾವು ಈಕ್ವಲ್ ಆಗಿ ಶೇರ್ ಮಾಡಿದ್ರೆ ಒಂದು ಕಾರ್ಬನ್ ಗೆ ಒಂದು ಹೈಡ್ರೋಜನ್ ಬರುತ್ತೆ, ಇನ್ನೊಂದು ಕಾರ್ಬನ್ ಇನ್ನೊಂದು ಹೈಡ್ರೋಜನ್, ಅದೇ ರೀತಿ ಬಾಂಡ್ ಮಾಡಿದ್ರೆ. ಓಕೆ, now 2 hydrogens ಇರೋದ್ರಿಂದ therefore 1 s and 1 p. This is s, this is p, that is px py pz, right? ಯಾವುದಾದ್ರು ಒಂದು p ಮತ್ತೆ s ಸೇರಿಬಿಟ್ರೆ ಏನಾಯ್ತು? sp hybridization. sp hybridization ಆಯ್ತು. s and p orbitals overlap ಆಯ್ತು, hybridization ಆಯ್ತು. Already I told you this is s orbit plus this is p orbit. These two overlap, s and p overlap, you get sp hybrid orbital, right? So how we are writing sp hybrid orbital? This is s and this is overlapping after p. So this is called sp hybrid orbitals, like that you get. Now observe here, for one carbon, these two we called as hybrid orbitals, sp hybridization, and we called hybrid orbitals. These two, this one and this one we called hybrid orbitals. Hybrid orbitals. Now observe these two, means let us assume this is px and now py and pz is there, right? These two are not participate in hybridization, right? ಇವೆರಡು ಹೈಬ್ರಿಡೇಷನ್ ಅಲ್ಲಿ ಫಾಲೋ ಆಗಿಲ್ಲ ಅಂದ್ರೆ ಇನ್ವಾಲ್ವ್ ಆಗಿಲ್ಲ ಅಲ್ವಾ. ಸೊ ಅವುಗಳನ್ನ ಏನಂತ ಕರಿಬೇಕು ಅಂದ್ರೆ ಅನ್ಹೈಬ್ರಿಡ್ ಆರ್ಬಿಟಾಲ್ಸ್ ಅಂತ ಕರಿಬೇಕು. ಯಾವ ಎರಡು p ಆಗಿರೋದ್ರಿಂದ ಅನ್ಹೈಬ್ರಿಡೈಸ್ಡ್ p ಆರ್ಬಿಟಾಲ್ಸ್ ಅಂತ ಕರಿತೀವಿ. These two we call unhybridized. Unhybridized p orbitals. p ಇನ್ವಾಲ್ವ್ ಆಗಿಲ್ಲ ಅದಕ್ಕೆ ಅನ್ಹೈಬ್ರಿಡೈಸ್ಡ್ p ಆರ್ಬಿಟಲ್ಸ್, s ಇನ್ವಾಲ್ವ್ ಆಗಿಲ್ಲ ಅಂದ್ರೆ ಅನ್ಹೈಬ್ರಿಡೈಸ್ಡ್ s ಆರ್ಬಿಟಲ್ಸ್, d ಇಲ್ಲ ಅಂದ್ರೆ ಅನ್ಹೈಬ್ರಿಡೈಸ್ಡ್ d ಆರ್ಬಿಟಲ್ಸ್ ಆ ತರ ಕರೀತೀವಿ. ಸೊ ಇನ್ವಾಲ್ವ್ ಆಗಿರೋವು ಅನ್ಹೈಬ್ರಿಡೈಸ್ಡ್, ಇನ್ವಾಲ್ವ್ ಆಗಿರೋವು ಹೈಬ್ರಿಡೈಸ್ಡ್. got it? Now observe for one carbon there is one sp hybrid, right? Now the structure, this is one hybrid orbital for one carbon. Okay, now this is one carbon. Now second carbon, carbon 2 hybrid orbitals. ಕಾರ್ಬನ್ ಮಧ್ಯೆ ಏನಾಯ್ತು? ಹೈಬ್ರಿಡ್ ಆರ್ಬಿಟಲ್ಸ್ ಓವರ್ಲ್ಯಾಪ್ ಆಗಿಬಿಟ್ಟು ಏನಾಯ್ತು? ಒಂದು ಬಾಂಡ್ ಫಾರ್ಮ್ ಆಯ್ತು. ಓಕೆ, ಅದೇ ರೀತಿ ಇನ್ನೆಷ್ಟು p ಆರ್ಬಿಟಲ್ಸ್ ಇದೆ? 2 ಇದೆ. ಅನ್ಹೈಬ್ರಿಡೈಸ್ಡ್ ಅಂದ್ರೆ hybridization ಗೆ ಇನ್ವಾಲ್ವ್ ಆಗಿಲ್ಲ. ಸೊ ಅವುಗಳನ್ನ ಏನು ಬರೀತೀವಿ? ಡಂಪಲ್ ಶೇಪ್. ದಿಸ್ ಇಸ್ ಒನ್ p ಆರ್ಬಿಟಲ್. ಸೊ ಇನ್ನು p ಆರ್ಬಿಟಲ್ಸ್ ಅನ್ನು ಯಾವ ತರ ಬರೀತೀವಿ? ಡಂಪಲ್ ಶೇಪ್ ಈ ತರ ಅಂದ್ರೆ ಸೆಂಟ್ರಲ್ ಈ ತರ ಏನು ನೋಟ್ಸ್ ಅನ್ನ ತೋರಿಸಿರೋದಿಲ್ಲ, ನೋಟ್ಸ್. ಓಕೆ, ಸೊ ನೋಟ್ಸ್ ಇಲ್ಲ ಅಂತ ಹೇಳಿದ್ರೆ ಏನು? ಅನ್ಹೈಬ್ರಿಡೈಸ್ಡ್ p ಆರ್ಬಿಟಲ್. ದಿಸ್ ಇಸ್ ಒನ್ ಅನ್ಹೈಬ್ರಿಡೈಸ್ಡ್. ಅದೇ ರೀತಿ ಇಲ್ಲೊಂದು ಇರುತ್ತೆ ಅನ್ಹೈಬ್ರಿಡೈಸ್ಡ್ p ಆರ್ಬಿಟಲ್. ಓಕೆ, ಸೊ ದೀಸ್ ಅನ್ಹೈಬ್ರಿಡೈಸ್ಡ್ p ಆರ್ಬಿಟಲ್ಸ್ ಓವರ್ಲ್ಯಾಪ್ ಸೈಡ್ ವೇ. ಈ ಅನ್ಹೈಬ್ರಿಡೈಸ್ಡ್ p ಆರ್ಬಿಟಲ್ಸ್ ಏನಾಯ್ತು? ಸೈಡ್ ವೇ ಓವರ್ಲ್ಯಾಪ್ ಆಯ್ತು. ಇದು ಒಂದು ಆಯ್ತು. ಇದರಲ್ಲಿರುವಂತ ಒಂದು ಕಾರ್ಬನ್ ಅಲ್ಲಿ ಇರುವಂತ 1 p ಆಯ್ತು. ಅದೇ ರೀತಿ ಇನ್ನೊಂದು ಕಾರ್ಬನ್ ಅಲ್ಲಿ ಇರುತ್ತಲ್ವಾ, ಅದೊಂದಾಯ್ತು. ಒಂದು ಕಾರ್ಬನ್ ಅಲ್ಲಿ ಎಷ್ಟಿದೆ? 2 ಇದೆ. ಸೊ 2 ಇದೆ ಅಂದ್ರೆ 1 ಬರ್ತಿದ್ದೀವಿ, ಇನ್ನೊಂದು ಬರೀಬೇಕು. ಓಕೆ, ಅದೇ ರೀತಿ ಇನ್ನೊಂದು ಬರೀರಿ.